Ladies and gentlemen, note 6.1 are on applications of Pythagorean Theorem. Before we get into the Pythagorean Theorem, we just want to talk about how to solve the following equations that we have in front of us. So you know how the inverse of addition is subtraction and the inverse of multiplication is division? The inverse of squaring something is square rooting it, because, for example, if I take 5 and I square it, I get 25. And if I square root 25, it brings me back to 5. So if I have the square root of something squared, they will cancel each other out and you will end up getting 5. So in order to undo the squaring here, I'm going to square root both sides. So I end up getting x is equal to positive 4. Okay? For right now, we're going to say it's positive 4. It's actually positive or negative 4, because negative 4, when you square it, will also give you 16. But for the purposes of our class right now, we're just going to say it's 4. Okay? And then same thing for number 2. I would square root both sides, and I would get a equals 3. Okay? So the definition, first of all, Pythagorean Theorem, we're going to apply it to right triangles right now. So the definition of a right triangle is a three-sided polygon with one 90-degree angle. Okay, and you guys already know that that's what makes a right triangle. So if I were to draw a picture of my right triangle, it would look as follows, with a right angle box in the corner. Okay, and then typically we call this side A and this side B, and then this last side here is called C. Okay, and C is has a really special name. It's really important to know what it is. C is always across from the right angle, and C is called the hypotenuse, and the hypotenuse is always the longest side. Okay, A and B are called your legs. And their legs, the legs here are interchangeable. So if I wanted to call this B and this A instead, that's totally fine. But I'm not allowed to call this C anything other than the hypotenuse. Okay? And in order for a triangle to be a right triangle, it has to satisfy the following equation. A squared plus B squared equals C squared, and this is called the Pythagorean Theorem. And what we're going to do in class next time I see you guys is we're going to actually prove it. We're going to see a proof of the Pythagorean Theorem to see why this works. Okay? So question number 3. Find the missing sides in the following right triangles. So right here, the first thing I'm going to do is identify which is my hypotenuse, which one is my C value. And it's the one that's right across from the right angle. So C is x, so this is my hypotenuse. And in order to use Pythagorean Theorem, I'm going to say a squared plus b squared equals c squared. Since x is the hypotenuse, a could be 5 or a could be 12. It's up to you. Since I said a is 5, I'm going to say b is 12. So I'm going to say 5 squared plus 12 squared equals x squared. Okay? 5 squared, I have to evaluate my left side of my equation using order of operations, so I'm going to do my exponents. So 5 squared is 25 and 12 squared is 144. And then I'm going to collect my like terms, so I get 169 equals x squared. And then to undo squaring something, I'm going to square root it. And when I take the square root of 169 right here, I end up getting 13. And that's a perfect square that I would like for you to have memorized, okay? So x is 13 in question number 3. In question number 4, the c value is the square root of 17 right here. So this is going to be my c value. This could be a or b. X could be A or B. So we'll call X A and we'll call 1 B, just so you can see that they're interchangeable. And the formula is A squared plus B squared equals C squared. But instead of A, I'm going to replace it with X. So it's going to say X squared, B is 1 squared, and C is the square root of 17, and I need to square it. Now, I'm not going to type in the square root of 17 into my calculator and then square it, because remember how we said that the square root and the square will cancel each other out? So this ends up being simply just 17. And like I said, I don't want you to type it into your calculator, but I want you to see how it's going to work out for us. So if I take 17, I square it, and then square root it, and then I square it, I end up getting 17. So it cancels out. So I end up getting x squared plus 1 squared, be careful, don't tell me it's 2 because 1 squared means 1 times 1. So x squared plus 1 equals 17. Subtract the 1 from both sides and I get x squared equals 16. Square root both sides and I end up getting x equals 4. So the side length that is missing in question number 4 is equal to 4. Okay? All right, last one on this page right here. If I have my right angle right here, that means that x is my hypotenuse, which means that A is 3 and B is 4, okay? So I'm going to say, I'm going to start with my formula. So I'm going to say A squared plus B squared equals C squared. And instead of A, I'm going to use 3. So 3 squared plus the square root of 32 squared is equal to x squared. So I end up getting 9 plus the square root of 32 is 32 equals x squared. And then when I add 9 and 32 together, I get 41 equals x squared. I'm going to square root both sides, and I'm going to say x is approximately equal to, because 41 is not a perfect square, so x is approximately equal to 6.4. Okay? Right, so for number 6, it says Jenna's changing a light bulb. She rests a 4-meter ladder against a vertical wall so that its base is 1.4 meters from the wall. How high up the wall does the top of the ladder reach? Round your answer to the nearest tenth of a meter. So we need to draw a picture of what's happening here. So here's our wall, okay? And we have a ladder that's resting against the wall. And the ladder is 4 meters long, okay? And the base of the ladder is 1.4 meters from the wall. And we want to know how high up the wall does the top of the ladder reach. So we want to figure out what this length right here is, and this is going to be called x. And we have a right triangle here. So this means that my C value is 4. So that means that this could be A or B, and 1.4 could be A or B. So I'm going to say A squared plus B squared equals C squared. And I'm going to say X squared plus 1.4 squared equals 4 squared. So now I get X squared plus, and then I'm going to square 1.4. So 1.4 squared should give us 1.96. Equals 4 squared is 16. Then I'm going to subtract 1.96 from both sides, okay? And I end up getting x squared is equal to 14.04, okay? So then once I'm done with that, I need to square root my answer. So I'm going to square root my answer and I get about 3.7. So square root both sides and you end up getting x is about 3.7 meters. Okay, so then we're going to say, therefore, the ladder reaches a height of 3.7 meters with the wall, or against the wall. Okay? All right, number 7, calculate the area of a triangular sail that has a height of 12 centimeters and a hypotenuse of 15 centimeters. So right here, I'm going to draw a picture of my triangular sail. And I'm sorry, we should say right triangular sail, because that's really important to have it be a right triangle. So right here, it says that it has a height of 12 and it has a hypotenuse of 15. So I know that C is 15 and A is 12, and now I need to solve for B. So I'm going to say A squared plus B squared equals C squared. Then I'm going to say 12 squared plus B squared is equal to 15 squared. So I get 144 plus B squared is equal to 225. I'm going to subtract 144 from both sides, and I end up getting B squared equals 81. Then I'm going to square root both sides, and I get B equals 9. So now I know that the B value on my triangle is going to be 9 centimeters, but it asked us to find the area. And to find area, I need to do base times height divided by 2, or I could say 1/2 base times height. And since my base is going to be 9 and my height is going to be 12, I'm going to take 9 times 12 divided by 2. And then I'm going to actually go ahead and do my multiplication here. So 9 times 12 is going to be 108. Divided by 2, I end up getting 54. So I'm going to say, therefore, the sail has an area, and sorry, this is a 5 in case you can't read that, an area of 54 centimeters squared. Okay? Question number 8, we're going to take up as a class together, so you don't have to worry about that one. But I do want you guys to do one last thing for me, please. There's something called Pythagorean triples. I want you guys to look up on the internet, what is a Pythagorean triple? And then I want you guys to find 4 examples of Pythagorean triples. And just to make sure that you're on the right track, one example would be 3, 4, 5. That's an example of a Pythagorean triple. I want you guys to find 4 more examples. So I want you to tell me, what is a Pythagorean triple? And give me 4 more examples of Pythagorean triples. And then we will talk about that next time I see you guys in class, as well as question number 8. All right, I hope you guys have a great day. Bye.